You could hear it from a mile away. A rhythmic exhaust blast rolling across the hills of West Virginia, the sound of a Norfolk and Western compound mallet dragging coal out of the hollows at walking speed. If you grew up near the Appalachian coal fields, you knew that sound the way you knew a thunderstorm coming over the ridge. And then, almost overnight, it stopped. Across the country, railroads had spent decades building steam locomotives of extraordinary power, machines that could move mountains of freight over mountain grades. Then, in barely 15 years, nearly all of them were gone. Number 10 on this list was a locomotive built completely backwards, and the railroad had a deadly reason for designing it that way. Number 5 may have been the most powerful steam locomotive that actually performed as promised. And number 3 came so close to beating diesel on pure economics that the railroad only gave up when the parts supply collapsed. Here are 15 steam locomotives America built to dominate, then scrapped almost overnight. Number 15. The Erie Triplex. The Erie Railroad's triplex locomotives were among the most ambitious steam designs ever attempted. Built starting in 1914, the Matt H. Shea and her sisters used a 2-8-8-8 two-wheel arrangement, 3 sets of driving wheels powered by a single massive boiler. On paper, the tractive effort was staggering, well above anything else on American rails at the time. In practice, the boiler simply could not produce enough steam to feed all 3 engine sets at speed. At anything above a walking pace, the triplexes ran out of breath. They could start enormous trains but could not keep them moving. The Erie tried them in pusher service on its mountain grades where low speed was acceptable. But even there, the maintenance costs were brutal. All were withdrawn by the early 1930s. The most powerful locomotive on paper turned out to be one of the least practical machines ever to turn a wheel. Pause for 1 second. Number 14. The Duluth, Misabe and Iron Range Yellowstone. The Duluth, Misabe and Iron Range operated in northern Minnesota, and its entire reason for existing was iron ore. Trainloads of it hauled from the Misabe Range to the docks at Duluth and Two Harbors, where the ore would be loaded onto Great Lakes boats bound for the steel mills of Indiana, Ohio, and Pennsylvania. The Yellowstones were built to move those trains. Baldwin delivered them starting in the early 1940s, and they were enormous. The 2-8-8 four-wheel arrangement gave them 8 driving axles, and the boilers were among the largest ever fitted to a simple articulated locomotive. A single Yellowstone could handle a long train of loaded ore cars on the gently graded ore division, a load that would have required 2 or 3 smaller locomotives a decade earlier. The Yellowstones stood apart not just for their raw power, but for how perfectly they fit a single narrow roll. The ore runs were seasonal. The mines shipped heavily from spring through late autumn, and in winter the railroad scaled back dramatically. The Yellowstones earned their keep in 6 or 7 months, then sat cold in the roundhouse until the ice broke on the lakes again. When the Duluth, Misabe and Iron Range began dieselizing in the mid-1950s, the calculation was simple. Diesel units could handle the ore trains with fewer crew changes and no water stops. They did not need the coaling facilities the Yellowstones demanded. The seasonal storage problem vanished because a diesel sitting cold started with the turn of a key, while a Yellowstone needed hours to build steam pressure. By 1960, every Yellowstone was gone. Not one was preserved. The largest simple articulated locomotives ever to haul iron ore became iron ore themselves, melted down in the same furnaces their freight had once fed. Number 13. The Santa Fe 2900 class. The Atchison, Topeka and Santa Fe put its 2 10-4 locomotives to work across the flatlands of Kansas, Oklahoma and the Texas Panhandle. With 10 driving wheels and a massive firebox supported by a 4-wheel trailing truck, the 2900s combined high tractive effort with sustained speed, a combination that made them exceptionally effective on long, level freight runs, where sustained horsepower mattered more than raw starting force. Santa Fe rostered them alongside its famous 484 passenger locomotives, and in some respects, the freight haulers were the harder workers, grinding through tonnage on divisions where the railroad earned its money, hauling grain, cattle, and manufactured goods westward. The 2900s could maintain higher sustained speeds than most 10-coupled locomotives because of the large trailing truck, which supported a firebox big enough to generate steam at rates that kept the engine working hard over long distances without the power falling off. That mattered on the Santa Fe, where freight runs could stretch for hundreds of miles across open prairie with no grade to speak of and no excuse for slowing down. The Santa Fe was among the most aggressive dieselizers in the country. By the early 1950s, its diesel fleet was growing fast, and the big steamers were retired in blocks. The 2900 class was gone before the decade was half over. None survived. Number 12. The Baltimore and Ohio EM1. Built by Baldwin in 1944 and 1945, these two 884 articulated locomotives were the last steam power the Baltimore and Ohio ever ordered, and they were built because the railroad had no choice. Wartime restrictions on diesel locomotive production forced the Baltimore and Ohio to accept steam for its heavy coal drags across the Alleghenies, even though the railroad's management already knew that diesel was the future. The EM1s were powerful and capable machines, handling tonnage over sandpatch and cranberry grades that would have required helper locomotives with older power. They performed well in every measurable way, but the moment the war ended and diesel builders could fill backlogged orders again, the Baltimore and Ohio started replacing them. The last EM1s were retired by 1960. The railroad preserved none of them. Machines built out of wartime necessity were discarded the instant that necessity passed. They were born into the wrong decade. Number 11. The Pennsylvania Railroad S1. This locomotive looked like nothing else on rails. Designed by Raymond Loewy and built at the railroad's Juniata shops in Altoona in 1939, the S1 used a 6-4-4-6 duplex drive arrangement, splitting the driving force between two sets of cylinders mounted on a single rigid frame. It was massive, stretching just over 140 feet with its tender. The Pennsylvania displayed the S1 at the 1939 World's Fair in New York, where it became one of the most photographed objects at the entire exposition. In revenue service, the S1 was fast but difficult to live with. Its enormous length meant it could not be turned on most standard turntables, and the railroad restricted it to the Fort Wayne division between Chicago and Crestline, Ohio. The S1 demonstrated what steam could achieve at high speed. It also demonstrated that pushing steam technology to its absolute limits produced machines too specialized to justify their operating cost. It was cut up in 1949, 10 years after it dazzled crowds at the fair. The pattern behind these retirements was not mechanical failure. Most of these locomotives worked. They hauled the tonnage they were designed to haul, at the speeds they were designed to reach. A diesel locomotive could be operated by a smaller crew. It did not need water stops every 100 miles. It did not need a fireman monitoring a stoker or shoveling coal. It did not need roundhouse facilities with ash pits, water treatment plants, and coaling towers. A diesel could be shut down at the end of a run and restarted in minutes. A steam locomotive needed hours to raise steam from cold, and leaving it under pressure overnight burned fuel and required a hostler to watch it. The railroads had spent decades and enormous sums building an infrastructure around steam. Coaling towers, water tanks, turntables, roundhouses, machine shops staffed with boilermakers, machinists, and pipe fitters. All of it became obsolete in less than a generation. The financial case for diesel was not subtle. It was overwhelming. And the men who ran the railroads were not in the business of sentimentality. Number 10. The Southern Pacific Cab Forward. No American steam locomotive looked stranger than a Southern Pacific Cab Forward. The engineer and fireman sat at the front of the machine, ahead of the smoke box, with the tender and boiler stretching out behind them. It was a steam locomotive built in reverse. Southern Pacific had a problem that no other railroad in the country faced at the same scale. Its main line over Donner Pass in the Sierra Nevada ran through dozens of snowsheds and tunnels, some of them extending for considerable distances. A conventional steam locomotive running through a long tunnel or snowshed filled the enclosed space with exhaust gases, smoke, and cinders. The crew, sitting behind the boiler at the rear of the locomotive, breathed all of it. Engineers passed out at the throttle. Some were overcome entirely. The cab-forward design solved this by putting the crew upwind of their own exhaust. The smokebox and stack trailed at the rear, and the fumes blew behind the train instead of enveloping the cab. The locomotives burned oil instead of coal, which made the reversed layout practical, since liquid fuel could be piped forward from the tender through the length of the boiler barrel. Southern Pacific built or converted well over 200 cab-forwards between 1910 and 1944, with the AC-12 class being the final and most powerful series. They were a signature of the railroad, as recognizable as the Southern Pacific's famous daylight streamliners. No other railroad in the world operated anything quite like them. When dieselization came to the Southern Pacific in the 1950s, the cab-forwards had nowhere else to go. They were engineered for one railroad's specific geography and one railroad's specific problem. No museum had the space for a locomotive that large, and no short line could use one. Every single cab forward was scrapped. The problem they were built to solve, crew asphyxiation in tunnels, simply ceased to exist the moment diesel power arrived. Number 9. The Pennsylvania Railroad. T1. If the S1 was the dramatic prototype, the T1 was the production model of the duplex concept. A 4444 locomotive built for high-speed passenger service, the T1 was ordered in quantity, 52 units between 1945 and 1946, the largest single order of duplex drive locomotives ever placed. The T1s were fast. They could sustain speeds well above 100 miles per hour on the Pennsylvania's racetrack flat main line across Indiana and Ohio. But the T1 carried a flaw that its engineers never fully solved. The driving wheels, split between two separate engine sets, were prone to violent slipping, especially when starting heavy trains or accelerating on wet rail. Crews learned to nurse the throttle carefully, but even experienced engineers could lose control of the wheel slip without warning. The reputation stuck. By the time the T1s were barely 5 years old, the Pennsylvania was already taking delivery of diesel replacements. The entire fleet was scrapped by the mid-1950s, many with less than a decade of service behind them. Number 8. The Norfolk and Western Y6B. This compound Mallet articulated locomotive hauled coal out of the coalfields of West Virginia and Virginia year after year with a kind of stubborn, unglamorous effectiveness that the flashier machines on this list never matched. Norfolk and Western built and maintained its own steam locomotives at its shops in Roanoke, and the Y6B was the product of decades of careful, incremental refinement. It used compound expansion, feeding exhaust steam from the high-pressure rear cylinders into the larger low-pressure front cylinders, extracting every available unit of energy from each pound of steam. The result was extraordinary thermal efficiency for a machine of its size. Norfolk and Western kept its Y6B locomotives in service longer than almost any other Class I railroad kept steam, not out of sentiment, but because the railroad sat on top of its own coal reserves, which made steam genuinely cheaper to run than diesel on its particular routes. The economics caught up eventually. As diesel power spread across the rest of the industry, the specialized knowledge needed to maintain compound steam locomotives grew scarcer, and the cost advantages that cheap coal had once provided narrowed. The last Y6B made its final run in 1960, rolling into the shops at Schaffer's Crossing in Roanoke one last time. Number 7. The Union Pacific Challenger. Built from 1936 onward, the Challengers were among the first articulated locomotives designed not merely for slow drag freight, but for genuine speed. The 4-6-6-4 wheel arrangement gave them large driving wheels on both engine sets, and Union Pacific used them on fast freight and even passenger trains across Wyoming, Nebraska, and Utah. They were versatile in ways that most articulated locomotives simply were not. Other railroads bought the design or close variations of it. The Delaware and Hudson, the Denver and Rio Grande Western, the Clinchfield, and several others operated Challengers in heavy service. Union Pacific alone rostered over 100 of them. The Challenger proved that articulated locomotives did not have to be slow, lumbering drag freight machines. They could run fast, ride well, and handle mixed traffic on a busy main line. That versatility should have given them a longer service life. It did not. When dieselization reached the Union Pacific in the 1950s, the Challengers went to scrap alongside everything else. A handful survived in parks and museums across the West. Union Pacific later restored its own Challenger 3985 to operating condition, one of the very few articulateds to escape the cutting torch and run again under its own steam. The rest, over 100 Challengers spread across half a dozen railroads, were gone before most Americans realized what was happening. Number 6. The New York Central Niagara. The S1B Niagara was arguably the finest 484 ever built, a locomotive designed not for brute starting force, but for sustained high speed running over long distances. New York Central assigned the Niagaras to its premier passenger trains between Harmon, New York and Chicago, running them at sustained speeds above 80 miles per hour for hours at a stretch. They logged enormous monthly mileages, routinely covering tens of thousands of miles a month, availability numbers that genuinely rivaled diesel performance. That was exactly the point. The Central's engineering team designed the Niagara to prove that a well-maintained steam locomotive could match diesel economics in the categories that the accountants measured: miles per month, percentage of time available for service, and cost per ton-mile of work performed. The Niagaras came remarkably close. But close was not good enough. The Central's board had already committed to diesel, and the Niagaras were withdrawn between 1953 and 1956. Not a single one was set aside for preservation. The finest expression of American 484 design went from revenue service directly to the cutting torch. Pause 1 second. There is something worth pausing on about the speed of the destruction. In most industries, when a new technology displaces an old one, the transition stretches over decades. Resistance builds. Nostalgia slows things down. Steam locomotives were different. The railroads did not gradually phase them out. They pulled them from service in large groups, towed them to scrap lines, and cut them apart as fast as the torches could work. Part of the reason was financial. A steam locomotive sitting in storage was not free. Its boiler remained a liability, subject to inspection requirements and insurance costs, even if it never turned another wheel. The railroads also needed the scrap value. Post-war steel prices made the metal in a retired locomotive worth real money, and the roads were spending heavily on new diesel fleets. Every scrapped steamer helped offset the cost of its replacement. Preservation was barely a consideration. A locomotive that could not earn its keep in revenue was worth more melted down than sitting on a siding. Pause 1 second. Number 5. The Pennsylvania Railroad Q2. A strong case can be made that the Q2 was the most powerful steam locomotive in the world that actually worked as its designers intended. The Q2 used a 4-4-6-4 duplex arrangement with a smaller set of driving wheels at the front and a larger set at the rear, all mounted on a rigid frame. Unlike the T1 passenger locomotive, the Q2 was a freight machine, and its measured performance was extraordinary. Dynamometer car tests on the Pennsylvania's main line recorded sustained drawbar horsepower output that placed the Q2 at or near the top of any steam locomotive ever tested under controlled conditions. The Q2 did not suffer from the same crippling wheel slip that plagued its passenger cousin. The freight service profile, with higher tractive effort demands at lower speeds, reduced the tendency for the drivers to break loose. The Pennsylvania built 26 of them between 1944 and 1945, and they worked the railroad's heaviest freight corridors across Pennsylvania and into Ohio. But the Q2 arrived at precisely the wrong moment in history. By the time the last units rolled out of Juniata, the Pennsylvania's leadership had already signed diesel purchase agreements. The post-war flood of available diesel horsepower, combined with the financial pressure to standardize on a single technology across the entire system, sealed the Q2's fate before it could demonstrate its long-term economics. The entire class was withdrawn by 1951. Most had barely 6 years of revenue service behind them. The Q2 was not a failure. It was a success that arrived too late to matter. Every one of the 26 units was scrapped, and no example of the duplex freight locomotive survives anywhere in the world today. Number 4. The Chesapeake and Ohio Allegheny. Built by the Lima Locomotive Works starting in 1941, the H8, universally known as the Allegheny, was designed for one task: dragging heavy coal trains over the steep grades of the Allegheny Mountains between Hinton, West Virginia, and Clifton Forge, Virginia. It was a simple articulated design with a 2-6-6-6 wheel arrangement, and by several measures, it was the most powerful reciprocating steam locomotive ever constructed. The Allegheny's combination of high tractive effort at starting and sustained horsepower at working speed was unmatched. Many powerful locomotives could deliver one or the other. The Allegheny could do both, which is what the grades demanded. The CO purchased 60 of them in total. They worked hard through the late 1940s and into the early 1950s, but the railroad began converting its coal divisions to diesel traction soon after. The Alleghenies were retired by 1956. 2 survived into preservation, one at the Henry Ford Museum in Dearborn, Michigan, and one at what is now the CO Heritage Center. The other 58 were scrapped. Pause 1 second. Number 3. The Norfolk and Western A-Class. If any locomotive on this list came closest to making steam genuinely competitive with diesel on pure economics, it was the A. Norfolk and Western designed and built the A-Class at its Roanoke shops, and the railroad's engineers approached the problem with a ruthless focus on thermal efficiency, mechanical availability, and shop turnaround time. The 2664 was a simple articulated locomotive engineered for fast freight service across the Appalachian grades. It could sustain high speeds with heavy trains, and Norfolk and Western's meticulous shop practices kept the A-Class available for service at rates that approached diesel availability numbers. The railroad operated its own coal mines, which gave steam an additional cost advantage that no other railroad could match. Norfolk and Western was the last holdout, and it held out longer than anyone expected. When the railroad finally placed its first diesel orders in the late 1950s, it was not because steam had failed on the operating sheets. It was because the supply chain for steam components was collapsing. Boiler tubes, specialty castings, and the skilled boilermakers who knew how to work with them were becoming impossible to source at any price. The A-Class locomotives were retired by 1960. All were scrapped. The scrapping of America's most powerful steam locomotives was not just a technological transition. It was an act of deliberate erasure. Railroads did not simply replace their steam fleets. They systematically destroyed the infrastructure that supported them. Roundhouses were torn down. Water tanks were pulled out. Coaling towers were demolished. Machine shops staffed with specialists who had spent entire careers building and repairing steam power were closed or repurposed. The goal was not merely to adopt diesel, but to eliminate any physical possibility of reverting to steam. Railroad managers understood that as long as the facilities stood and the parts were available, there would always be operating men arguing to keep a handful of steamers in reserve, arguments that cost time and money to overrule. Destroying the infrastructure settled the argument permanently. The speed of this erasure meant that preservation was almost entirely an afterthought. Of the thousands of heavy steam locomotives built in the United States during the 1930s and 1940s, fewer than 100 survived into the museum era. The rest became scrap steel, reborn as automobiles, appliances, and structural beams. Number 2. The Norfolk and Western John Henry. Completed in 1954, The John Henry was a steam turbine electric locomotive that represented the absolute last attempt to keep steam technology competitive against diesel on an American railroad. It used a coal-fired boiler to generate steam that drove a turbine, which in turn powered electric traction motors, the same type of motors found in diesel-electric locomotives. The idea was elegant: combine steam's ability to burn cheap Appalachian coal with the smooth, controllable power delivery of electric drive. Norfolk and Western tested the John Henry in regular freight service alongside its conventional steam fleet and its growing diesel roster, running it on the same divisions under the same conditions. The locomotive worked, but it was mechanically complex in ways that a conventional reciprocating locomotive was not, and the diesel it was supposed to beat was simpler, cheaper to maintain, and available from multiple manufacturers with full parts support. The John Henry was officially retired in early 1958 and scrapped a few years later. It was the last new steam locomotive concept tested in revenue service on a major American railroad. Not a prototype sitting in a test plant. A working machine, hauling freight, trying to prove that steam still had a future. It did not. The age of steam traction in American railroading ended not with a catastrophic failure, but with a quiet ledger entry showing that coal could no longer compete with diesel fuel for the work that needed doing. Number 1. The Union Pacific Big Boy. There is no other way to end this list. The 4884 was the largest steam locomotive ever built, designed to haul heavy freight over the Wasatch Mountains between Ogden, Utah and Green River, Wyoming, without the helper locomotives that the steep grades had always required. Union Pacific took delivery of 25 big boys between 1941 and 1944. They did exactly what they were designed to do. They pulled enormous tonnage over mountain grades at sustained speeds that no previous articulated locomotive had achieved. The big boy was not experimental. It was not a compromise. It was a production locomotive that went to work every day and delivered. When Union Pacific dieselized in the 1950s, the big boys were retired alongside everything else. 8 survived, scattered to parks and museums across the West, standing silent for decades. Then Union Pacific completed a years-long restoration of Big Boy 4014, returning it to full operation. When 4014 rolls through a town today, thousands of people line the tracks to watch. They come because they understand, without anyone needing to explain it, that they are watching something that should not exist anymore. A machine from a world that chose to destroy every trace of what it had built, running again under its own power, proving that some things are harder to erase than the accountants believed. America did not scrap its most powerful steam locomotives because they failed. It scrapped them because something cheaper came along, and the railroads were not in the business of preserving magnificent machines. They were in the business of moving freight. If you found this worth your time, subscribe so you do not miss the next one. The coaling towers are gone. The roundhouses are parking lots. But somewhere in a museum yard in Cheyenne, Wyoming, a big boy still builds steam on summer mornings, and the ground still shakes when it moves. Pause for 1 second.